Okay, welcome to the screencast going through rate of reaction. So just a quick recap regarding what we have learned in class yesterday. So we've learned the collision theory, which states that a chemical reaction can only take place if the reacting particles collide with each other effectively. So not all collisions will result in a reaction. So what are effective collisions? Effective collisions are when reacting particles collide with sufficient energy greater than or equal to activation energy, though you do not need to know what's activation energy, and they must collide in the correct orientation. Okay? So the rate of reaction isn't just dependent on the frequency of collisions, but rather the frequency of effective collisions. The greater the frequency of effective collision, the faster the rate of reaction. So we'll see that when we explain how a factor affects the rate of reaction, we should always end with how the frequency of effective collision has changed. So we've learned that there's 4 factors affecting the rate of reaction. Concentration of reactants, which we know that refers to aqueous solution, because to have concentration is the number of moles of solute divided by the volume of solvent. Okay, so that's concentration. Pressure of the system has to do with gases. Particle size of reactant is for solid reactants. And temperature of reaction mixture affects all reactions, okay, any type. So if for the reaction that we've been observing, calcium carbonate reacting with hydrochloric acid, if I want to increase the rate of reaction for this particular reaction, what should I do? Which factors can I change? Okay, so how do we answer this question? First, we note that calcium carbonate is a solid. So therefore, what I can do is I can increase the particle size. Increase the surface area by reducing particle size. Now, what do we mean by reducing particle size? So, example, instead of lumps, we choose powder. Okay, choose to have the powdered form. Okay, next, I have HCl, which is in aqueous state. So I know I can also increase the concentration of HCl used. Then of course we have temperature. Which will work for all reactions. Okay, increase the temperature, which will increase rate of reaction for any reactions. Okay, so why is that the case? An increase in temperature will increase the rate of reaction because reacting particles will gain kinetic energy. They will move faster. So once the particles move faster, they will collide with each other more frequently. Hence, the frequency of effective collisions will increase, thus increasing the rate of reaction. So I've asked you to start this line. Remember to always explain how the rate of reaction is affected based on the frequency of effective collisions. Next, concentration of reactants. This is for aqueous solutions. An increase in the concentration of reactants will increase the rate of reaction. Why is that the case? When the concentration is increased, so let's recall concentration is number of moles of solute over volume of solution. Okay, volume of the solution. So when concentration is increased, that is to say I have greater number of moles of my solute within the solution, there are more reacting particles per unit volume. With more reacting particles per unit volume, they are closer to each other, hence they collide with each other more frequently. The more they collide, the higher the chance that the collision is a effective collision. So frequency of effective collisions increase, and thus the rate of reaction increases. Next, let's look at pressure. This is only for gases. So though this is for gaseous reactants, increases the rate of reaction. If you look here, the concept is actually very similar to that of concentration, increasing concentration. Here on the left, I have something of a lower pressure. Now, what can we think of pressure as? We can think of pressure as the amount of force that the gaseous particles are exerting on the walls of the container. Okay, so imagine gas particles are moving randomly and rapidly in all directions, right? So as it hits the wall, it exerts a tiny force on the walls of the container. Okay, so the pressure that this container is experiencing is actually from the number of moles of gas inside. So I can increase the pressure by reducing the volume that these particles exist in, or I can pump in more gaseous particles. So what we see is when I increase the pressure by, say, reducing the volume, the particles are now closer together. And when they are closer together, or we can say there are more reacting particles per unit volume, same as concentration, that means they are closer together and they will collide with each other more frequently. Okay, so that's this part here. Closer together. Okay, so they are physically closer together with a greater number of particles per unit volume. So you can see that this part is actually the same concept as that of increasing concentration. The frequency of effective collision increases, and thus increasing the rate of reaction. The last factor that you will learn is on particle size. So we know that the smaller the particle size of the solid, okay, the greater or the larger is the total surface area. What do I mean? If you look at this diagram here, okay, say I have a cube that's 4 by 4 by 4. The total surface area is 96 cm square. Okay. Now, looking at the same volume, same total volume, but broken into 2 by 2 by 2 cubes, we can see that the total surface area has now increased to 192 cm square. Okay, so for the same volume, by breaking it up into smaller pieces, we are increasing total surface area. And how is that significant? Now, when there's a reaction, we know that a collision between particles must take place. Where can the collision occur in a solid? The collision can only take place on the surface, okay, on the surface of the solid. So when we break the solid up into smaller pieces and increase the surface area, what we are effectively doing is increasing the areas that can have collisions. Okay, so instead of just this one large block, the inner side now can also be subjected to collisions. Okay, so a decrease in particle size or an increase in the total surface area of the solid reactant increases the rate of reaction. Why? Smaller solids have a larger total surface area than lumps of solid. Okay, this is assuming they have the same total volume. The area of contact between the reacting particles will increase. The frequency of effective collision increases, and hence the rate of reaction increases. So we can see a simulation for this. Say I have low surface area, which means that only the outer edge can react. Okay, only after they are reacted, then the inner red particles are exposed for collision. Okay, so let's see here. Okay, so it took us 30 seconds or so, right? Let's reset this. Okay, this time I have a high surface area. The powder is such that each powder is one particle. Okay, now you can see that we don't just have to react with the outer layer of red particles. Now the red particles are sufficiently spaced apart such that the blue particles can come in and collide with any of them. Okay, so let's see here. Let's play the simulation. Oh, wow, instant. Okay, it's so fast that I just scroll up and down and then can't see anymore. Okay. Okay, so that's how surface area or particle size affects the rate of reaction.